Welcome to Free Coding Academy's Machine Learning Series Part 3. What is the Logistic Regression ML model? So first up, what is logistic regression? So logistic regression is a machine learning model which helps computers make yes or no decisions. And this is used when the output that you receive from the model is binary. So examples of binary outputs could be yes or no, on or off, approved or rejected. So there's only two possible answers. So it takes the input data and predicts the probability of something happening. So how does logistic regression work? In the previous video, we covered linear regression. And so linear regression finds the linear relationship between two variables to make predictions. In contrast, logistic regression uses an S-shaped curve called the sigmoid function to make predictions. The sigmoid function squashes predictions into a range between 0 and 1, which is ideal for probabilities because probability is always calculated from 0 to 1. A probability of 0 means it will never happen. A probability of 0.5 means it might happen or it might not. Probability of 1 means it will certainly happen. So the decision threshold. Once we find a probability using the sigmoid function, we set a threshold, which is usually 0.5. If the model predicts a number above the threshold, such as 0.8, which is greater than 0.5, we make the decision of yes. If the model predicts a number below the threshold, such as 0.3, which is less than 0.5, we make the decision of no. So what are some examples of how logistic regression can be used? It can be used to predict whether a loan will be approved, so approved versus rejected are your two binary options, diagnosing whether a patient has a disease, they have the disease versus they do not have the disease, and filtering spam emails, spam versus not spam. So what are some limitations of logistic regression? Logistic regression, like linear regression and all the other ML models, is not perfect. It struggles when the data is not linearly separable. Not linearly separable means you cannot clearly distinguish between yes and no. In that case, we need to use more complex ML models like decision trees or neural networks. And that's it. Thank you so much for watching. Please like, comment, and subscribe, and watch part 4 on decision trees next.